Hey class, Absolute 5 here, and today we're going to talk about ratios. Ratios. So what is a ratio? The ratio of a number A to a number B, let's use capital B for now, excuse me, is their quotient. So here are the ways to write, well, here are ways of writing ratios. There are three ways. I can't talk right now. There are three ways to write ratios, and they are, you have A to B, A colon B, and simply A over B as a fraction. So the example I'll give will be, let's say, so as usual, when I talk about letters like this, they are generalization. They're like any number I want them to be, and you plug them in depending on the condition of the number. So in this case, A is a number, B is a number, so it could be whatever you want it to be. So for example, I'll let A be 1 to 2 as B be 2. So you get 1 colon 2 or 1 over 2. Now, some of you might think, like, why would I want to write this as a ratio? Or why are they saying fraction as a ratio? The reason for this is because different fields have different names for certain things. So understand that, yes, a ratio can also be called a fraction. But at the same time, the same idea is that not everything is going to be the same thing. So let's use a different case here. So can I write this as a ratio? Let's say I told you to divide 2.5 by 3.15. Can I write that as a ratio? And my answer to you is yes, you can. So this becomes, that's my amazing arrow. Let's just put a little line. There we go. I write this as a ratio, 2.5 over 3.15. Now, I'm going to make this into a whole numbers. So this is going to be 250 by 315. How you may ask? Let me just get some more space and explain how. Remember, this is technically 3.15 into 2.15. Sorry, 2.5. How did I get that? I simply move the decimal point over to the right twice. So remember, whatever I do on the outside, I have to do on the inside. And that's why I got 250. I got 315 over 250. Now when you divide this, I'm just going to, well, we're not really actually going to divide this. We're just going to reduce this because it doesn't divide perfectly. You should get 50 over 3. You get 50 over 63 as your answer. How did I do that? Well, I divide both of the numbers by 5. Because why? Because when a number ends with a 0 or 5, you can use 5 to divide both those the numerator and the denominator by that number. And you can check yourself that that's exactly what you get. And can I reduce further? The answer is no, because there's nothing, 50 and 63 have nothing in common other than 1. Okay? Now, what about, let's use something different. Let's say I gave you a rectangle, right? Let's say this is 7 feet and this is 7 feet. I said 7 feet twice. 5 feet and 7 feet. And then the example is asking you, 5 find the ratio of its width to its length. Now, length being the longer piece, so this is my L, and the shorter piece is my width. So knowing this, I have to set my length, which is 5 feet. So in a sense, I'm writing this as right. Sorry, I think I got it confused. It's the other way around. This is my length, and this is the width. Sorry. Because when I ask you to write this as width over length, how am I getting this? Because remember, a ratio... Actually, no. Oh, so sorry. I made a mistake. No, I was right the first time. I am so sorry, guys. I was right the first time. The longer piece is the length, and the shorter piece is the width. The only reason why this formula is written as width to length, because it says it in the problem. Find the ratio of its width to its length. So we just learned that when I say 1 to something, I'm saying that number over the other number. Therefore, that's why it's going to be 5 over 7 feet as my answer. Whatever that is as a decimal, you can figure that out for yourself. Or not. You know what? Nah, I'll do it for you. Why not? 7 into 5. Let's see, 0, 0, 7 into 7, 49. I subtract, I get 1. I add a 0. 7 divides into 10 once. So I get 7 minus 10 is 3. Add another 0. 7 goes into 30, 28 times. I bring down, I need more space. So then I get 2. And this number, see, remember that rule I told you about when you divide in decimals? I already know this number is going to keep going on and on and on and on and on and on, and we don't have time for that. Like I said, I'm stopping at the third decimal place because I know this number is going to go on for a very long time. So I'm not going to really worry about that much. So for homework, I'll just give you let's say a school has a ratio from boys to girls from 2 to 3. If there are 30 boys in the school, how many boys, sorry, not boys, how many girls are in the school? And I know some of you will figure it out right away. So, and if not, well then, let's review real quick. These are three ways to write a ratio, and that a ratio is pretty much a fraction. If you really break it down, it's just basically a fraction. It all depends on what field you're doing, because ratio can be used probably in chemistry, baking even, because it's mainly ratios, whatever have you. And that's basically it. So that's the lesson for you guys. I hope you enjoyed it. Be sure to like, share, and subscribe to this channel. Mash that bell button for more content. And I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.